Hello, survey people. We're going to do profile leveling next. We're going to take our differential survey and we're going to add to it. Profile leveling combines distance measurement with differential leveling. So we haven't measured distance yet. We're going to set out points in a line where there's a change in the ground slope. That means whether it gets steeper or levels off or changes from what it is. Then we're going to measure the elevation of the points where we put the pins and graph them with an exaggerated vertical scale. And that'll give us a useful profile for planning our excavating or whatever we want to do with the ground. Like this. Here's a profile. There you see it. We've got these dots connected with a line, and it gives us a profile of the ground as if we dug a trench in it and looked at the side of the trench. Then it's got a slope line on it. We'll show you how to do slopes in a bit. But this is an XY graph. You've all done those at some point. We need some more equipment. So for profile leveling, to add to the equipment that we've been using, we need a 100-foot fiberglass tape. Now notice the handle is folded. When you're not actually using the tape, always fold the handle. When they get left open, they get broken. You'll see several of the tapes are broken. And when we measure with the tape, we're going to round the distances to the nearest foot. That's all we need. Then there's a set of 11 chaining pins. So you see this ring's got 11 pins on it. You count the pins before you go out. There should be 11. When you come back, you should have the same 11 pins on your ring. The field book looks a bit different. We're going to use 2 pages. Okay, so up here on the left side of your page, there's your title and your column headings. We've got 2 new columns. We've got an IFS, that's an intermediate foresight, and then it runs over on the next page, put a line down, make another column, and that's the ground elevation. Okay, so here's our differential survey, just like it was before, but it's spaced down the page. Here it is, and here it is at the bottom with the closing. It's spaced down the page because we've got this new information, this 0 plus 0, 0, and so on. These are distances from the initial point. The initial point is 0. We write it 0 plus 0, 0 to differentiate in the book, to make sure that when we see this number, we know we're talking about a distance that we measured with the tape. So we've got these, and along with that, we've got an IFS and a ground elevation. So here at 0 plus 0, 0, the IFS, the intermediate foresight, 6.8 belongs to that. And then you subtract 6.8 from a rounded to a tenth height of instrument, and you get your ground elevation. You round that there. When you get the height of instrument, you round it to a tenth if you're measuring pins. Then you can subtract from that. You don't have to do the rounding every time. It lessens the chance for error. To the right here, remarks, comments. Top of the bank, level ground. Top of the slope, halfway down the slope. Those are notes where you set the pins along your line. So with your map and these notes, you could, at a later date, if we needed to, you could put the pins back approximately where you had them when you did this survey. Notice at the top of the right page, the same information's there, the equipment, the date, your party, and all of that's still where it was before. The second page in the profile has the map, and you see the map's on a different page. It's not on the graph page, it's on the left side of the page. And it's got a profile line on it and labeled. I'll show you that right side up in a second. And then the right side of the page, the graph paper side, has the profile on it. Okay. Here's the map, and it's a map just like we've been doing. There's your differential survey laid on the map, and here's our profile line. It's just a straight line as the crow sees it, and it's labeled profile line. So that's where our pins will be. Here's the profile page, and you see the horizontal profile, vertical scale in the left margin. We make a baseline up 2 spaces to give us space for the horizontal scale numbers here, because you'll notice in your book there's no margin here on this side. There's a big margin over here. I'll show you how to do this in a bit, but we're going to plot our points and draw our profile and any slope lines we want before we write in the slope formula numbers and the scale numbers up here, because until we lay the profile out, we don't know where it's going to go across the page, and we don't want to draw across it. But I'll show you that sequence in a while. So this is the field procedure. We go out, we get our equipment, our level, and the rod, and tape and pins, and we go out to where we want to do a profile, and we find a benchmark. Then we lay out the pin line. I'll show you that in a moment. It'll be a straight line, and the pins will be where there's a change in slope, where you're going along and it gets steeper. That break there will get a pin. Then you set up the instrument, shoot a back sight, and get your height of instrument to 100th. You're still doing differential at this point. And then round the height of instrument to 1/10 in the space right above it. Now you can take an IFS, an intermediate foresight, at 0 plus 0, 0, the initial point, the first pin, and you can calculate the ground elevation. You just subtract intermediate foresights just like you do a foresight, and you'll get a ground elevation. The IFS and the ground elevation are in tenths. They don't need to be in hundreds. Now move the rod to the next pin, the second pin. Look through the scope and see if you can read the rod. If you can read the rod, then tape the distance from 0 plus 0, 0, and write that in your book below 0 plus 0, 0 on the next row, and get the IFS and the ground elevation for the second pin. Move the rod to the third pin. Look through the scope, see if you can get a reading on the rod. If you can, tape the distance from the second pin and add it to the first distance. Put it in your book, get the IFS and the GE, the ground elevation. Remember, the tape distances are just to the nearest foot. That's all you need. And continue on until you get all the IFSs that you can take from that height of instrument. If you're going up or down a hill, you're going to get to where, when you put the rod on the pin, you can't see it because it's too far down the hill or up the hill. So now you need to do a turning point. So you choose a turning point away from the pin line. It can't be on the pins. It's got to be away from the pin line, someplace separate. And use that to move to a new height of instrument. So you're back to differential there. And remember, you're shooting to 100th. If you are going to continue shooting pins or IFSs, round the height of instrument to 1/10 in the space above the height of instrument in 100th. So just continue in this way until all the IFSs are taken and all the ground elevations calculated. You've shot and calculated the ground elevation for all the pins you've laid out. At this point, you're done with the profile. Now you go back to differential and you use turning points as you need to return to the benchmark and close your differential survey. Then you're done with the gathering the data. This is how you set the pins up. Okay, you choose a place for your initial point, your 0 plus 0, 0, the first pin. Then you put it down, and you pick a target out down where you want your pins to be, somewhere out past it. Here we've got a bush to use for our target. And now the team of you, 2 of you, get in position. The liner upper stands back behind the first pin and sights down that first pin to the target. The pin dropper, now these are the technical terms we use, the pin dropper and the liner upper. So anyway, the pin dropper's got the pins with him. And he goes out and he finds a place where the grade changes, where you've got a grade break. Okay. He holds the pin out to his side so the liner upper can sight across this pin and the pin he's got to the target. And he guides the pin dropper side to side until it lines up. Go that way a little bit, and then when it's lined up, that's good. He signals and the pin dropper drops the pin down in line. You've got a straight line with a pin at each grade break from the initial point out toward the target as far as you want to go with the pins. This is kind of a picture of how you do it. Here's our profile. There's the ground out there. Like I said, if we bulldozed a trench there and looked at the side of it, it'd look like that. So we lay our pins out everywhere there's a grade break, where it gets steeper or levels out, we put a pin. And we've got a benchmark up here, and we bring our instrument out and we take a backside and we get a height of instrument. And we bring the rod in and put it on the initial pin, the first pin. And we can shoot our IFS, our intermediate foresight, over on that pin. Only needs to be a 2 to a tenth, so this gets pretty fast after a while. All right, so now we move the rod to the second pin, and we look through the scope and see if we can get a reading on the rod first. And if we can, then we get our tape, and we tape out the distance, it's 12 feet, and we write in our book 0 plus 12 in the line after. The first line after your height of instrument will be for 0 plus 0, 0. It'll have that, and the IFS and the ground elevation for 0 plus 0, 0. Then the next line has 0 plus 12, and we're going to shoot our IFS and calculate our ground elevation for the second pin. So we move the rod up to the third pin, look through the scope and see if you can get a reading. Well, we can. So we tape from the second pin to the third pin, and that's 15 feet. We want the distance from the initial point, so we add 12 and 15. 0 plus 27 is how far that pin is from the initial point. Then we can shoot our IFS and do our ground elevation. To the next pin, the fourth pin. Can we see it? Yeah, we can see it. So we get our tape out, and it's 18 feet from the third to the fourth pin. 18 plus 27 is 45. 0 plus 45. Then we can shoot our IFS and get our ground elevation. So we go up to the next pin and we look through the scope and we can't see it. It's too far up the hill. Well, that means we've got to do a turning point. So we do a turning point again off your pin line, somewhere else, not on your pins. You shoot a foresight, we get the elevation for the turning point. Now we can move our instrument and take a back sight and get a new height of instrument and round it in your book to a tenth to continue shooting the pins. So now we can see this pin, so we measure 7 feet. 45 plus 7 is 52. This pin's at 0 plus 52 from the initial point. We can take our IFS, move the rod down, look through our scope, see if we can see that. If we can see it, we measure. It's 35 feet. So 52 plus 35 is 0 plus 87 is where we're at there, and we can take our IFS. Okay, now we move down to this one, and we look through the scope, and we can't see it. It's too far down the hill. Well, we got to do another turning point. So here's turning point 2. Foresight, and we're back to differential. Got the ground elevation at turning point 2. Back sight, new height of instrument. Now we can continue measuring 6 feet, 0 plus 93. We can take our IFS there on that pin. Move the rod down to the last pin now. Look through the scope. Can we see it? Yeah, we can see it. So we measure, it's 48 feet from the last pin. 48 plus 93 is 141, so we write that 1 plus 41. That's 141. That's our last pin. We can take our IFS and get our ground elevation at the last pin. Now we're done shooting the pins. We've got the information we need. So now you would just go back to your differential and redo your turning points back to the benchmark, get back to the benchmark however you want, and close your differential survey and do all that. So you'd close and do your math check and error of closure and allowable error. So now you have this data page. You're going to use, to make your profile, the distances here in the first column and the ground elevations. That's what we're going to use right here. So at 0 plus 0, 0, the ground elevation is 98.5. At 0 plus 5, it's 98.2. At 0 plus 16, it's 96.4, and so on. So these are the elevations we're going to graph up the page, and this is the distance we're going to graph across the page. Okay. First, we have to make a scale in our book to lay our profile on. Now, what you want to do is flip over another page and use a scratch page of your book for the calculations to determine your scales, calculate your slopes, whatever slopes we do. And if you use a scratch page in your book, it'll let you see later how you did these calculations. You'll have little notes. This is how I did this. Put little notes in there. You'll write the results after you've drawn the profile, because we don't know where the profile is going to be on the page, so we don't want to write something on there and then have the profile go through it and have to erase it or mess it up. Now the scale that we need, the scales we need a horizontal and vertical scale. They need to be whole numbers, and they're always written this way: 1 inch equals, 1 inch equals. When you look at a map, it says 1 inch equals a mile or 100 feet or whatever it says. It doesn't say half an inch. So it's 1 inch equals 4 feet, not 3.5 feet. Or 1 inch equals 40 feet, not, say, 38 feet. Why? Now, 38 is a whole number. What's wrong with it? Well, it's hard to do multiples of 38 as you go. It's easy to do multiples of 40. So what you want is a scale that's as big as you can make, so the profile is as big on the page as you can make it, with a scale that's easy to use. The vertical scale will be exaggerated to emphasize the elevation changes, like this. Your horizontal scale might be 40 feet, 1 inch equals 40. Your vertical might be 1 inch equals 4. They're not the same. That'll make the profile exaggerated. Since the page is lined 1/8 by 1/4, multiples of 4, when it's possible, make it easy to plot the points. It's not always possible to use 4s, but if you can, it makes it easier. So here's your field book. It's ruled 4 1/4 by 6 1/4, but just use 4 by 6. Because we're going to use the bottom 2 rows. We're going to strike our baseline here to leave space to put our horizontal numbers. There's no margin at the bottom here. There's a wide margin at the left. You can put your vertical numbers in. So just use 4 and 6. Okay. So the horizontal scale, got 6-inch page. Say we went 350 feet. Well, we got to fit 350 feet in a 6-inch page. So you just 350 divide by 6-inch page. Gives you feet per inch. That comes out 58.33 feet per inch for 1 inch. Well, we don't want that for a scale. The next whole number is 59, but that's not very good to use. So we'll use 1 inch equals 60 feet. You got to round up. You can't round down. It won't fit on the page if you round down. So we're using an easy number to work with. 1 inch equals 60 feet for the horizontal scale. The vertical scale, up the page. You got a 4-inch page. Okay. Go to your ground elevations and find the lowest one and the highest one and subtract those, and that'll show you what distance, what vertical distance you have to fit on the 4-inch page. So if we've got the high is 110.6 and the low is 96.4, we've got 14.2 feet change in elevation from low to high that we need to fit on our 4-inch page. So 14.2 feet per 4-inch page gives us 3.55 feet per inch. We need to round up, so we round up to 4 feet. 1 inch equals 4 feet will be our vertical scale. Now we need to do one more thing with the vertical. We need to decide where the elevation is going to start. We don't start at 0 like we do with the horizontal, okay? Because we've got to fit these numbers on our page. So find the low point. It's 96.4 here. That's the low point. So we come down to our baseline and we put in 96 there. We draw our baseline across. Here's our horizontal numbers. And we start at 96. It's just a little bit lower than 96.4. Now every inch up the page, we're going to go up 4 feet. So we count 8 spaces up and we've increased 4 feet, so we're at 100. We go 8 spaces up, we're at 104. That's how you put your vertical scale in and decide where to start. Notice that the horizontal and vertical scales are not the same. So here's the profile page. Let me show you the order in which the information goes on the page. First thing is the horizontal scale. You figure that out on your scratch page and make your baseline up 2 spaces and fill in your horizontal scale. Here it's 4 spaces or an inch, so 1 inch equals 20. Then we've got to put the vertical scale over here. So we decided we're going to start at 96 and we're going to use 1 inch equals 4 feet, so 96, 100, 104, 108, and so on up there. Every 8 spaces up. Now we can plot our points with our ground elevations. We go out as far as each pin goes and we go up and we put a dot at each elevation at the distance it is from the initial point. Then we connect them with the straight edge and there we've got a profile. Okay, that's the easy part. The scale's really the hardest part of making the profile page. It's not really that hard, but plotting the points is easy. So now you can draw and calculate a slope. In this case, we're doing slope from end to end. So we draw in our slope line and do the calculations on our scratch page. Now you take the numbers from your scratch page and now you can copy them neatly onto your profile in an open space. Now that we know where the profile is, we know we can put this information up here. We could have put it down here, but here's our information. The horizontal scale is 1 inch equals 20 feet. The vertical scale is 1 inch equals 4 feet. Here's our slope calculation. I'm going to show you how to do a slope in a moment, but this slope is 10.1% end to end. This is how you do a slope. Okay, and again, on your scratch page, you do this and then copy it neatly. You can draw a slope between any 2 lines, any 2 points. So the first slope is end to end. Let's do a high-low slope from the low point to the high point here. There's our formula. Our formula is vertical change over horizontal distance times 100 gives us a percent slope. A percent slope is handy because that's what we dial in the lasers. Okay, so let's draw our slope line from low to high. There it is. And what's our distance we're going to use? Well, our whole distance to the end is 120 feet. And back here, the low point is 16 feet from 0. So if we subtract 16 from 120, we'll get 104. It's 104 feet from this low point to the high point. Okay, that's our H. Now we need to know our V. So the low point is 96.4. And our high point is 110.6. 110.6 minus 96.4 is 14.2. That's the V, the vertical distance from low to high. So that's our V. So put that in our formula, put the distance in our formula, the h, do the calculation. Your calculator will give you this fraction here, times 100. We've got 13.7% slope. That's the slope of this line from high to low. And hey, it makes sense. If this line from end to end is 10.1%, and this line is steeper, then it's a higher number. It's 13.7. It's a steeper slope. That's how you do slopes.